All right, so we're now going to talk about what is called the vertical line test. And so the vertical line test, if we think about it, our x values will fall on, sorry, trying to get it to where it will write, our x values go left to right when we're counting our values, but when we add our y values, they go up and down, which would be vertical. And so our vertical line test just double checks that for every x value, there is only one y value. So if we look at this first one, well, when I did my vertical line test, this x value of -3 has two y values. So I know that this is not a function because it doesn't pass the vertical line test. And again, not that the vertical line test is any different than what we were doing before. It is another way to make sure that for every x value, there's only one y value. It's just a visual way. And so I highly suggest taking your writing utensil and just kind of, since we're working on computer screens, using that to kind of make your vertical lines on the computer screen to make sure that these vertical lines don't cross. Oh, see, there's another one. More than one point on our graph. And so you technically don't need to draw them. I'm drawing them because that's the only way you can see where I'm checking vertical lines. But when I look through these vertical lines, that's what I'm looking for. In all of these instances that I circled, we crossed more than once, which means that our x values have multiple y values, making it not a function. Whereas when we look at this other graph over here, and with these really steep lines make it look like maybe there is, but if I look at my x values that I have here, they only cross my y values or my graph in one place, meaning that for every x value, there is only one y value. And so this is a function. So again, we call this the vertical line test because it's a visual way to double check that for every x value, there's only one y value. All right, so using this vertical line test, determine if each graph represents a function. So if I use this vertical line test here, I'm checking through my graph, and at no point on my graph when I draw my invisible vertical lines do I ever cross this one more than once. And again, that more than once is when I draw a line, it crosses my graph in one place. And then when I draw my new line, it crosses my graph in one place. And so this is a function. Because for every x value, there is only one y value. So again, I'm doing this here, and basically what I'm making sure is that for every point, it's only one point for every x value. And so then I get here, and I was doing really good until we got to the end here, and they are on the same x value. Therefore, this is not a function. Now, I want to point out it is not always the ones that are dots and only dots that create not a function. Any graph, unfortunately, I don't have an example here, unless we were to flip C sideways, rotate it 90 degrees, where we could show where a line or a curve becomes not a function. So when I look at C the way it is now, each time I do my x values, I am only crossing my function in one place. Therefore, it passes the vertical line test and is a function. I don't know why I put an S at the end, but it is a function. All right. In our next video, we're going to go back to the multiple representations and how we can use, say, a graph or a table or whatever we may have in order to complete another representation. So until then, 8th grade,